This lesson is from Mrs. Cucci's Contemporary Mathematics class. We are on lesson 1.1, and today we're going to talk about inductive and deductive reasoning. So the first thing we're going to talk about is something called inductive reasoning. What inductive reasoning is it's the process of arriving at a general conclusion based on observations that you make. So you're going to write that definition down. So the process of arriving at a conclusion based on observations or specific examples. So we call the conclusions that we come to through our reasoning either conjectures or hypotheses. Okay, so many times, instead of trying to prove that our conjectures or our hypotheses are correct, we instead try and disprove them. That's often much easier to find something that will disprove them than will prove. So what we wind up looking for is something called a counterexample. So let's look at an example of finding a counterexample. The 10 symbols that we use to write the numbers 0 through 9 are called digits. So the question is the sum of two digits, or two two-digit numbers, always a three-digit number? So if I take two two-digit numbers, like 14 and 18, if I add them together, that's my sum, will I always get a three-digit number? We want to find a counterexample that will show that we don't always get a three-digit number. So I'm looking for an example to kind of prove my statement wrong. So an example of a counterexample may be 13 plus 26. When I add those together, I get 39, which again is not a three-digit number. So I've got a counterexample here that proved my hypotheses wrong. So the next thing we're going to talk about is something called inductive reasoning. Okay. So again, inductive reasoning, if we go back up and look, inductive reasoning is the process of arriving at a conclusion based on observations or specific examples. Okay. So we're going to use inductive reasoning to help us find a pattern and find the last number in this pattern. Okay, so the first one I've got 3, 12, 21, 30, and 39. So what I'm doing is I'm looking for a pattern. How am I getting from 3 to 12, 12 to 21, 21 to 30, and then 30 to 39? So what I might first start to think about is could there have been addition used? So one way that I can figure that out is what number can I add to 3 to get 12? Well, I know 3 plus 9 will give me 12. So how I check this to see if this adding 9 will work is I have to take the next number and I have to add 9 to that as well and see if that gives me my next term, 21. It does. Then the next one, 21 plus 9, and you do have to check all of them. 30 plus 9 is going to give me 39. So my pattern is adding 9. Okay, so to get my next term, I have to do 39 plus 9, which is going to give me 48. All right, so let's look at B. I've got 3, 4, 6, 9, 13, 18. So I need to figure out the pattern here. So why don't you take a second, and I want you to think about that pattern and see if you can come up with it. it doesn't look like it's going up an even amount. To go from 3 to 4, I've added 1. To go from 4 to 6, though, I've now added 2. And then 6 to 9, I've added 3. Now I'm starting to get the idea of a pattern here. I'm not adding the same number every time. What I'm doing is each time I've moved to the next number, I've added an extra number. Okay, so 3 to 4 I added 1, 4 to 6 I added 2, 6 to 9, 3, 9 to 13, 4, 13 to 5, 18. So it would stand to reason that to get the next number in the pattern, I would add 6. 18 plus 6 is 24. So again, it's all about finding patterns. Let's look at C. 3 to 12, 12 to 48, 48 to 192, 192 to 76. So you have to keep in mind that we're not always going to be talking about moving from one term to the next using addition. Sometimes it will be multiplication, sometimes it will be division, sometimes it will be exponents. So you have to kind of give them all a fair shot here. So if I were to look at this using addition, I would have to add 9, okay? But when I add 9 to 12, that doesn't bring me anywhere near 48. So let's think about maybe multiplication. What would I have to multiply 3 by to get 12? Well, I know 3 times 4 is 12, okay? But let's see if I have the same kind of thing happen here that happened in A, where I added 9 each time. Let's see if I multiply by 4 each time, if that gives me what I want. So 12 times 4, if I multiply that, that gives me 48. So it looks like I'm on the right track. 48 times 4, that looks like that's going to give me 192 as well, which means I found my pattern. My pattern is to multiply by 4. So I'm going to take my last term here, and I'm going to multiply that by 4. And I'm going to find that to be 3,072. All right, so we've got one more to try here. Now again, remember, it's not always going to be a constant, like adding 9 or multiplying 4. Sometimes our pattern changes, right? So let's keep thinking in terms of finding that pattern. Let's start with addition. 3 to 6 would give me 3. I would add 3. 6 plus 3 would give me 9, which doesn't bring me to 18. So it doesn't look like addition is going to work for me. Let's skip to multiplication. 3 times what is 6? Well, 3 times 2 is 6. But 6 times 2 is an 18. So what if, like I had my pattern over here, we increase that factor by 1? 3 times 2 is 6. 6 times 3 would give me 18. It looks like it's going to work. 18 times 4 is 36. 36 times 5 is 108. 108 times 6 is 216. So it looks like that pattern's going to work for me, which means I need to take 216 and multiply it by 7. Oh, wait, that didn't work for me. Let's back up. I got a little ahead of myself here. Let's backtrack. My apologies. Let's try that again. 3 times 2 is going to give me 6. 6 times 3 is going to give me 18. 18 times 4 in no way, shape, or form gives me 36. I apologize. But I know that 18 times something does give me 36. That's 2. So it almost looks like I'm working backwards here. 36, I went 2, 3, 2. Let's try 3. 36 times 3 does give me 108. 108 times, let's go back to 2, it's going to give me 216. And then 216, we're going to go back to 3, is going to give me 648. Okay, so you're going to make mistakes, you're going to mess up the pattern, that's okay. You just go back and you fix it and you try it again. All right, so that's using inductive reasoning, so specific examples or an observation or finding a pattern. All right, so we're going to use inductive reasoning now to identify a pattern in each list of numbers, and then we're going to use that pattern to find the next number. This is a little bit harder, okay? So our pattern here, we've got 1, 1, 2, 3, 5, 8, 13, 21. So we want to find the pattern here. So why don't you sit on it and think about it for a minute. Okay, so first thing I want to do is I want to think about, could I be using addition? So if I look at this closely, there's nothing that I'm going to add to 1 to get 0 that's going to be constant, or 1 to get 1. So 1 plus 0 gives me 1, but 1 plus 0 again does not give me 2. So then we think about, okay, what if I did 1 plus 0, which gives me 1, and then 1 plus 1, which will give me 2. But then I would want to go 2 plus 2 to follow the pattern, and that's not going to give me 3. So that pattern doesn't work. Okay? So let's try again. How about if I take my first number, 1, and my second number, and I add them together? Will that give me my third number? Yes. So what I'm looking at doing is taking the two numbers before, adding them together to get my next number. 1 plus 2, 3. 2 plus 3, 5. 3 plus 5, 8. 5 plus 8, 13. 8 plus 13, 21. And last but not least, 13 plus 21 is going to be 34. So the pattern here was to take the last two numbers in the sequence and add them together to get the next number in the sequence. So again, let's try B. Again, these are a little harder, so it takes a little more time to find that. Okay, so this is actually a really tricky pattern. So here's how we're going to do this. To get the next number in the pattern, I'm going to take my first number and my second number, 2 plus 3, which gives me 5. That's going to give me that first number here. Okay? Then I'm going to take this second number and I'm going to add 1, which is going to give me my 4. Okay? So again, add these two, that gives me 9. Add 1 to this. Add these two, gives me 14. Add 1, gives me 16. All right, so we're going to add the numbers together. 1 plus 4 plus 6 gives me 11. Add 1, 7. 1 plus 1 is 2, plus 7 is 9, which gives me this. Add 1, which is 8. This gives me 9 plus 8, which is 17. Add 1, which gives me 9. So that's a really tricky pattern. I don't expect you're going to be doing ones that are that difficult, but I wanted to give you an idea of how these patterns can really be created. All right, let's keep going. Let's talk about deductive reasoning now. Okay, so deductive reasoning is the process of proving a specific conclusion from one or more general statements. So deciding something given a whole bunch of general information. It's a conclusion that can be proved to be true by deductive reasoning. We call that a theorem, okay? So a conclusion that's proved to be true by deductive reasoning is called a theorem. So you're going to see this word pop up quite a bit. All right, so let's look at a couple everyday situations and build some deductive reasoning from it, okay? So the first situation is one player to another in a Scrabble game says you have to remove those 5 letters. You can't use Texas as a word. So what kind of reasoning or theorems can we pull from that statement? Okay, so something that maybe we can decide based on saying we can't use the word Texas as a word could be all proper names are prohibited. prohibited meaning you're not allowed to use them. Okay, proper name is the name of a state. Okay, so that would be a proper name. So we could say based on this statement, we deduce that all proper names are prohibited in Scrabble. Okay. All right, so here's another one. Advice to college freshmen on choosing classes. Never sign up for a 7 a.m. class. Yes, you did it in high school, but mom wasn't always there to But mom was always there to keep waking you up, and if by some miracle you do make it to an early class, you will sleep through the lecture when you get there. So what can we deduce from that statement? So I suppose we could say that all people need to sleep at 7 a.m. So therefore, you sign up for a 7 a.m. class, and you will sleep through the lecture, or not make it to class. All right, so let's look at using inductive and deductive reasoning and determining which one to use when. Okay, so let's consider the following procedure. We're going to select a number. We're going to multiply that number by 6. We're going to add 8 to the product, divide the sum by 2, subtract 4 from the quotient. So let's give that a shot. Let's start with the number 4. Okay, so here's 4. So we're going to multiply this number by 6. Then we're going to add 8. To the product and divide that by 2 and subtract 4. Okay. Repeat this procedure for at least 4 different numbers and write a conjecture that relates. All right, so there's my first one. Let's try for the next one 7. So we're going to multiply times 6. We're going to add 8. We're going to divide by 2. And we're going to subtract 4. Let's try 11. Oops. 11 times 6, 66. 66 plus 8 is 74. 74 divided by 2 is 37. And 37 minus 4 is 33. Last one, let's try a big number, 100. 100 times 6 is 600. 600 plus 8 is 608. 608 divided by 2 is 304. 304 minus 4 is 300. All right, so we want to now write a conjecture that relates to the result of this process, so what we wind up with in the end, okay, to how it's related to its original number. Okay, so how are 4 and 12 related? 7 and 21, 11 and 33. And 100 and 300. So looking at those, it looks like to me our original number can be divided into our result. Okay. So I would say that that is what my conjecture is, that our original number is going to be a factor of, or can divide evenly into my result. Okay, so our conjecture is the result of the process that we did 3 times or 4 times from the original number selected. So what we've used is we've used inductive reasoning. So part B says we're going to use a variable to try that and see what happens when we try and prove this conjecture. Okay, so I'm going to choose the variable n. So I'm going to start by multiplying n by 6. Oops, that shouldn't be there. And then I'm going to add 8. I'm going to divide by 2. And then I'm going to subtract 4. So what I've gotten now is n and 3n. So does my conjecture hold true? Can n divide into 3n? Is n a factor of 3n? And using deductive reasoning, I would say that we have proven that theory. Okay, so that's your lesson for today. Make sure all of your notes are filled out, and you're going to go on to the practice document next, and that will be your homework. Thank you.